So I hope that you have finished answering all these 10 questions within 15 minutes. In this question paper or in this mock test video, you can find questions from medium to tough level. And mostly I have tried to include questions from electromagnetic theory because I was receiving a lot of requests to do or include questions from EMT. Okay, and also I'm receiving requests to add questions from measurements and electronic instrumentation. We'll be doing that next in the next part or in the upcoming sessions. Okay, so here you can find mostly questions from electromagnetic theory, waveguides, likewise. Okay, the first question is question number 1. The ratio sigma by omega epsilon is dash. The various options given are 1. Intrinsic ratio, 2. Loss tangent, 3. Conduction ratio, 4. Dissipation factor. Okay, so we have discussed about this term in very detail while discussing the waveguide video. In that we have discussed that this is nothing but loss tangent. Okay, and it is generally represented by the letter delta. So this is loss tangent, and this loss tangent can also be called as dissipation factor. It is not intrinsic ratio or it is not conduction ratio. It is the dissipation factor. It is some loss. Okay. So this is actually the dissipation factor or loss tangent. So from the options A, 1 and 2, no. B, 1 and 4, no. C, 2 and 3, no. D, 2 and 4 is the correct answer. Okay. So sigma by omega epsilon is called delta, which is loss tangent, or can also be called as dissipation factor. Moving on to the next question. The next question is from transmission lines. So I would request you to watch these theory videos or these formula revision videos also. These are actually quick revision videos of waveguides or electromagnetic theory, which I have included in the subject playlist. Okay. So next question. A transmission line has a characteristic impedance of 100 ohm and beta, which is the, what is beta? Beta is a phase constant. Beta is equal to 1 radian per meter. The inductance per unit length when f, which is a frequency of operation, is equal to 2 gigahertz is dash. Okay, so before looking, I have written the correct answer here. D is the correct answer, which is 7.96 nanohenry per meter. Okay, the equation for finding the inductance per unit length is equal to, because we know that transmission line we can represent as various circuit elements. So while discussing the transmission line video, I have discussed that in the beginning itself we can draw the transmission line as a combination of various circuit elements like resistance, conductance, inductance and capacitance. So here we are trying to find what is the inductance per unit length, and the equation is beta into Z0 by omega, where beta is phase constant, Z0 is a characteristic impedance, omega is the angular frequency, which is in radians per second. But you see, if you see in the question, you can see the frequency is given in hertz. So you can write this omega as 2 pi f, right? 2 into pi into f. Now we have all the terms and all the terms are given in the question also, and we can substitute, right? So beta is 1 into Z0 is 100 by 2 into pi into f is 2 gigahertz, that is 2 into 10 raised to 9. And if you solve it, you'll be getting the answer as 7.96 nanohenry. Okay. Okay, you won't be seeing that if I write it there. So I'll be writing in the next or this side. If you solve this, you'll be getting the value as 7.96 nanohenry per meter it is. Okay, this is the inductance per unit length. So it is not just Henry, it is Henry per meter. So correct answer here is option D is the correct answer. Next question is from antenna session. The efficiency of an antenna having loss resistance is equal to 30 ohm and radiation resistance is equal to 60 ohm is dash. Okay, so we will be doing a video on the formula revision of antenna very soon. So this is actually related to the antenna session, and we need to find the efficiency, and the efficiency in terms of the loss resistance and radiation resistance is given by eta is equal to radiation resistance by radiation resistance plus loss resistance into 100. percentage. Okay, since it is a percentage value, so into 100 percentage. So this is nothing but 60 by 60 plus 30 into 100. That is 60 plus 30 is 90. So it is 60 by 90 into 100. And you can write this as 66.66 percentage. Okay, correct answer is option C is the correct answer. Just note down this equation. This is very important. That is, if you want to find the efficiency of antenna in terms of the loss resistance and the radiation resistance, this is the equation. Next question is from optical communication session. We have done a video on the entire optical communication, all important topics. Please do watch that video. It has been included in the optical communication playlist. Okay. The question is the cladding which surrounds the fiber core dash. That is, what is the function of clad? So if you see the general structure of an optical fiber, you can see there is a central core. Covering that, there is a cladding, and then there is a buffer or a protective material. So this is a general structure of an optical fiber. Now, the light is actually traveling through this core region, this region, okay? And the light is getting total internal reflected and it is traveling through this core region. And the core region is selected in such a way that it is having the maximum refractive index as compared to the cladding, or it is having a refractive index always greater than that of the cladding region. So this is the cladding region. I'll shade it. This is the cladding region here. So it is surrounding the core. Now, the function of this cladding is actually to guide the light through the core, or it prevents the dispersion of light from the core region, or it confines. You can say that this is the actual sentence. It confines the light within the core itself, and it prevents the spreading of the light. Okay, so that is actually the function or the use of having a cladding region. That is the role of cladding. Okay, it is not acting as a protecting layer, or it is not for any other purpose. It is just to confine the light within the core, or it is used for guiding the light through the core. Okay, so that is the correct answer here. C, helps to guide the light in the core region. Okay, so please note these points. And also, whenever you are selecting a material for core and cladding, always the material of core region is having the refractive index more than that of the cladding region. And this prevents the spreading of light out of the core region. Okay, so that is the correct answer for this question. Option C is the correct answer. Question is question number 5, and it is from the Superheterodyne receiver session. Okay, this is a very commonly seen type of question, but some people are actually facing some trouble with this question. So that's why I've included such a question in this video. The question is, in a superheterodyne receiver, receiver, intermediate frequency is 450 kilohertz. FS is source frequency. Okay, source frequency is 1000 kilohertz. Then local oscillator frequency and image frequency are dash. We need to find both. What is a local oscillator frequency and what is a image frequency? Now, what is the concept of superheterodyne receivers intermediate frequency stage or IF stage? Here we are actually mixing the local oscillator. There is a local oscillator. I have actually explained in one of my videos about this concept. There is a local oscillator which is producing a frequency of FLO. This frequency is actually mixed with some, that is your source frequency, Fs, and you will be getting a intermediate frequency FIF, or you can call it Fi or whatever. That is a concept. So this is a mixer. In this mixer, what is happening? You're mixing the frequency from the local oscillator with the source frequency, and you will be getting a intermediate frequency. Okay. Now, this intermediate frequency can be calculated using the equation, that is FIF is equal to FLO minus Fs. Okay. That is, actually we are using the convention that we are actually comparing these frequencies. If FLO is greater than FS, we'll take FLO minus FS. And if FS is greater than FLO, we'll be taking FS minus FLO. But for the time being, since we don't know what is the, what is the local oscillator frequency, we'll take this as an equation, FLO minus FS. That is local oscillator frequency minus the source frequency we'll take as a intermediate frequency. And here, what is the local oscillator frequency we need to find? So what will be FLO? FLO from this equation is equal to FIF intermediate plus source frequency. Okay. So that is the local oscillator frequency. Now we are going to find this intermediate frequency we know, source frequency we know. So we are going to just add these two, and that is 1000 kilohertz plus that is also in kilohertz, so 450. So the answer will be 1450 kilohertz. Okay, so this is your local oscillator frequency. So that is correct. Now we need to find image frequency. Now what is the equation for image frequency? Okay, image frequency FIM, that is image, FIM is the image frequency, is equal to your source frequency Fs, capital Fs, plus 2 times intermediate frequency. So actually you can calculate this image frequency without even calculating the local oscillator frequency, because you know what is intermediate, you know what is source. Okay, so you just have to use this equation before even finding the local oscillator frequency. You can use this equation and find the image frequency. Okay, so what is source frequency? It is 1000. All values are in kilohertz, so don't worry. 1000 plus 2 into 450. So that is 450 into 2. It is 900. So I'm going to substitute that here, and the value coming is 1900 kilohertz is the image frequency. Okay, we'll be doing a video on superheterodyne receiver. Actually, I'm doing all these videos in sequence. Various requested topics I'm including in my videos as theory videos. I'm not discussing all the unwanted theory. I'm only including topics and equations and the important core concepts only. Okay, so I request you to please watch these theory videos also, rather than just focusing on only the questions. You need to know what is the concept also, right? So please do watch those videos. Anyway, the answer here is option C, which is 1450 kilohertz and 1900 kilohertz are actually the local oscillator frequency and the image frequency. Okay, so I hope the concept of this image frequency and intermediate frequency and everything is clear. I hope the equations are also now clear to you. Okay, now moving on to the next question. Consider the following, which is not a digital modulation. I've given not in quotes because we need to find which is not a digital modulation. The options are, there are 3 options and there is these 3 candidates are there, and we need to find which option is correct. The first candidate is pulse position modulation. Is pulse position modulation a digital one? No, it is not a digital modulation. In digital modulation, we actually need to digitize the signal. But in pulse position, we are not actually, that is, it is not digitizing. In the second one, pulse code modulation, while discussing the digital modulation schemes, the first thing we discussed was PCM. So it is actually a digital modulation. Then pulse width modulation, is it a digital modulation? No, it is also not a digital modulation. So the correct answer here is which is not digital modulation, means PM and PWM are not digital modulation techniques. Okay, so option A, 1 and 2, no. B, 2 and 3, no. C, 1 and 3, yes, that is the correct answer. 1, 2 and 3, no. Okay, anyway, if 2 is included, you cannot select that option because you know that PCM is a digital modulation. So this option is also wrong, this option is also wrong. The correct answer is option C is the correct answer, which is PPM, pulse position, and pulse width modulation are not digital modulation techniques. Okay, so that is the correct answer for question number 6, which is option C. The next question is again from Waveguide session. So we have discussed about all these things. That is question number 7 also and question number 8 also in the Waveguide revision video. Okay, so please do watch it. So the question number 7, the phase velocity Vp and the group velocity Vg in a waveguide is related to C as dash. So phase velocity, group velocity, the product is equal to C square, where C is the speed of light, which is 3 into 10 raised to 8 meter per second. So what is Vp, what is Vg, everything we have discussed, and its product is equal to C square. Okay, correct answer is option A is the correct answer. So if you are watching that video, you'll be knowing that how this is coming as Vp into Vg is equal to C square, how it is coming, you will be knowing. Now, moving on to the next question. The question is, a rectangular waveguide has a dimension of 5.1 centimeter into 2.4 centimeter. Now, when some question is showing a data like this, you should be, and if it is related to the rectangular waveguide, you know that for a rectangle, there is a wider section and there is a narrow section. There is a wider dimension and there is a narrow dimension. This wider dimension is width, this is breadth. Okay, sorry, it is breadth and this is width. Now, anyway, if I'm confusing, just know that there is a wider dimension and this one is a narrow one. So, if it is 5.1 cross 2.4 means this is 5.1 and this is 2.4. Now, we have discussed about these dimensions in very detail in the beginning. This is called as A and this is called as B. So, when somebody is studying rectangular waveguide or somebody has studied rectangular waveguide, when and if somebody is saying that this is A, this is B, you should be always knowing that A is the wider dimension, B is the narrow dimension. So, this A value is given as 5.1 centimeters and B is given as 2.4 centimeters. Now, what is the question? For dominant mode T10, this thing also we have discussed. For a rectangular waveguide, the dominant mode is T10 mode. The cutoff frequency is dash. Okay, so the dominant mode is a mode with the lowest cutoff frequency. Now, what is the cutoff frequency? In the end of that waveguide video, I have discussed that the equations for finding the wavelengths for these modes, that is the most prominent modes, especially for the dominant mode, the wavelength lambda 10, that is for T10 mode, the wavelength is equal to 2a, that is twice the wider dimension. Okay, now we don't need wavelength here, we need the frequency. So frequency F10, what is F10? It will be C by lambda 10. Now what is lambda 10? It is 2a. So this is the equation for finding the cutoff frequency for the dominant mode. Now just you need to substitute this C here. C is 3 into 10 raised to 8 by 2 into, this is 5.1 centimeters into 10 raised to minus 2 meters. So you can take it to the numerator and 8 will be now 10. So this is the sum you need to solve to find the cutoff frequency of dominant mode, which is T10. And if you solve it, the value you will be obtaining is 2.94 gigahertz. If you could remember this, because for rectangular waveguide, the dominant mode is always T10 mode, and this is the minimum frequency. Okay, so cutoff frequency for the dominant mode is the, that is if the mode is T10 and it is the dominant mode, means that mode is having the lowest frequency or lowest cutoff frequency. And for the case of rectangular waveguide, the lowest cutoff frequency is this. Okay, 2.94 gigahertz. Okay, so the correct answer for this question is 2.94 gigahertz is the cutoff frequency for T10 mode. I hope these equations are now familiar to you. I'll write the general equation once again. So F10 is C by lambda or we know that C by lambda is 2a, so it is C by 2a. Please note this down because we know the dominant mode is T10 for a rectangular waveguide. Anyway, the correct answer is option A is the correct answer. Next question is the 9th question. The question is polarization is characteristics of EM wave that gives a direction of dash. We have discussed about polarization in the transmission line video towards the end. Okay, so please do watch it if you want to know more about the polarization. This question is asking the basics of polarization. Polarization is actually, we say that the wave is circularly or linearly or elliptically polarized based on the direction of orientation of the electric field component. Okay, it is not magnetic field component or it is not any other component. It is the electric field component. Based on its orientation, we say that the wave is linearly polarized or circularly polarized or elliptically polarized. So the correct answer is A, electric component of wave with respect to the ground. It is based on this, its direction, or based on the electric field component's direction or orientation, we characterize wave as what type of polarization it is having. Okay, so that is the correct answer. Question 9, correct answer is option A. Moving on to the next question, is from communication systems or modulation, analog modulation. What will be the total modulation index if a wave is AM modulated, that is amplitude modulated, with 3 sine waves with modulation indices 25%, 50% and 75%. So total modulation index MT, I don't know whether we have discussed about this in the formula revision video. If not, please note it down. If some wave is modulated with 3 waves with various modulation indices, then the total modulation index is the square root of the squares of individual modulation indices. Here if you see, the modulation indices are given in percentage, but we know that modulation index is actually a, it is most probably or most commonly it is a floating point or a decimal number. Okay, so we don't need 25%, we need 25%, means 25 by 100, it is 0.25. Similarly, 50% means 0.5. 75% means 0.75. So the total modulation index is the squares of m1 square plus m2 square plus m3 square. So please note this equation. Here m1 is 0.25, m2 is 0.5. So you have to substitute those values. 0.25 square plus 0.5 square plus 0.75 square. If you take square root, it will be 0.93 is the total modulation indices of this end result. Okay, correct answer is option B is the correct answer for this question. So question number 10, the correct answer is option B, where MT, which is the total modulation index, is 0.93. Okay, so these are the questions which I have included in this video. So I really hope that you could get familiarized with some of the most important concepts of EMT, because mostly the questions were from EMT, also from other subjects, because since it is a mock test, you have to include questions from multiple subjects. Okay, so I really hope that you found this video useful. This is the 9th part of mock test. So if you found this useful, please do share this video with your friends also, and also give it a thumbs up to make me sure that you're finding it useful. And if you want more videos, please do subscribe to the channel. Please do follow the Facebook page. I'll be posting the notes of these videos, that is the questions for the mock test. I'll be posting all the questions, and also if I'm doing some videos on theoretical video, I'll be posting the notes over there. You can download it, or you can download the images from there. So again, I'm telling it, if you found it useful, please do like it and share it. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.